We are going to show how to integrate the dynamic link library that's produced in CKFLUID chemistry module with Matlab. So once we produce this DLL, it's possible to integrate it in several types of programs. So here we show how to use it inside any Matlab program. So as soon as one has the chemistry information introduced into CKFLUIDSOFT, then as soon as we click on the compile button, or we click on compute chem button, there are a number of files that are created that could then be used to integrate the CKFLUIDSOFT into Matlab or C++ program or Fortran and Java programs. So for the Matlab case, so let's see a number of files that one would need. So there are basically two files that are required for the CKFLUIDSOFT to be integrated with a Matlab program. The dynamic link library, and then a chemistry jar, which is a Java program. So the chem kinetics could be 32 bits or 64 bits, depending on the type of Matlab that one uses. So for those who operate on a 64-bit OS, so that would then produce one 64-bit program, or sometimes the two of them would be produced, and then the user may be required to supply the appropriate one. Basically, the chemistry.jar can select the appropriate chem kinetics. So these are the two types of files that are required. So the files that are created are listed in this folder here. So this is the working directory that we set up at the beginning. So those files are then created. So in this example, so there is only one chem kinetics 32 bits DLL that produced, which has been produced under Windows XP 32 bits. So this is the one that's produced. So here we also use a 32 bits Matlab to run the case. So basically we have these two files which are then required to run. And then we have a chem test that would be used under Matlab in this case. So this chem test requires the presence of the two files. Basically, chem test just represent any Matlab application that's written by any user to then get access to the chemistry data that's included in the chem kinetics DLL. So we're just going to see what actually is in the chem test that will allow a Matlab program to then run the chem kinetics DLL. So this is the file called chemtest that then contains the method given to the user to look at and see how to run it. So this is just a demo that the user can use, and then it can be inspired from here then to run a Matlab program. So this one here is just a C1. So let's see the Matlab one. So the Matlab one is in this format here. This is a Matlab chemtest.m. So there are some explanations on the top that explains some variables which are used. Since we are then using a Java program to access those, so the explanation of the parameters that one can access are just listed at the top. Those explanations could also be found on the Java program that's given inside the folder. So at the top we clear Java, we then just clear the garbage, and then we supply the basically the working directory that contains the chem kinetics DLL, and then we supply those information, and then we set up the Java path, which is self-explaining. And then after setting up this Java path, the file will then go and load and prepare the chemistry based on the current directory that has been set up at the top there. So that's this. So we supply some data, initial data here, so which could be any data that the user may use. And then we go to the main point, which is the loop, the looping point. So in this case, we try to loop over all the chemistry data that's included inside the chemistry. We just loop inside to display them. So this is the number of chemistry data. This variable, which is a chemistry, has been created at the beginning, but it's basically just represent the number of chemistries which is included in the chemistry.jar that we supplied here. So that's the chemistry variables. It's also the size of the chemistry array that we have there. So this data is the same. So then from here we access the chemistry array, which is just an array or a vector array that contains all the chemistries. So from here, each chemistry, which called C here, contains a number of species, the number of reactions, and then from there we set the kinetic parameters and values that we want to use for computation of the rate, the source terms, and then the heat of reaction. So from here we supply the T, the P, and then the C dot, and then the concentrations. So we use some default concentrations which are included inside the software. So some default. In this case here we didn't set any concentrations. We just use the default one that comes with the C, but the user may update, change them to any number that he wants. But we use the default here. And then from here we compute the source term. So computing the source term will give us these values, these three values, and the rate. The display is just a program which is inside the chem test, which is then used to access the information that have been computed through the compute chem here. So basically the main steps which are taken to use the CKFLUIDSOFT are just these two lines of programs which set up the values and then compute the source terms. So these are the two lines of code and then the looping point that the user may then use. So we get the chemistry, we set the value, and then we compute the source term. So the display is just to show how to access those values. So from here, the C, which is the chemistry variable, is then used to just display the information that have been computed. So the species, the concentration which was given, the mass source, and then the heat source. So since the heat source is coming as an array, so in Matlab, the arrays, they start to be counted from 0, and then there is only one source term for heat. So there is only one of them. So and then in below we also show how to access the rate. There are two ways of doing it. One could be used by doing the reshape, or just by using a very long array and then changing the position for the next data. So each reaction contains a certain number of data, and then we skip them and then display them. So this shows how one can use and display those values. So the position of each of this one represents the forward, the reverse rate, the equilibrium constant, the heat of reaction, the net rate, and then the reaction stoichiometry by itself. So those are shown there, and then they are displayed easily. So the pointers to those positions are listed here. Not all the positions are being used, and then the user may feel free to use them to set some values and parameters inside. So that's basically what it takes. So the critical point is just this looping point here. So that's how we use CKFLUIDSOFT inside a Matlab program. Now for the case of testing only, we can run the chem test that we just showed, and then just run it and see what it will display as data which is in it. So let's run the program and then show the values that it will display. So when we click on enter, so the program is then run, and then the values that are contained inside are then displayed. So this is what we get based on the concentrations, the default ones. The user may update them to run and do anything he wants. So from here. And then for this case here, the last two reactions have been set up with rate constant of 0, so that's why the net rate are being 0, but the heat of reactions are computed. So these are the heat of reaction. All the reactions have been irreversible. We put -1 to mean it's irreversible. And then the reverse rates are 0 because they are all forward reactions. So they are displayed on this place. So the heat is displayed there, and the source terms are displayed there. So the user may just access all these values to do whatever he wishes to do. So that's what it takes. That means that integration within Matlab is very easy, very straightforward, and then that's it. Thanks a lot.